In this demonstration, we have a model of a vehicle that is going to climb a hill. We need to add a 4-speed transmission and a controller for that transmission to the powertrain model. To do this, we're going to use SimDriveLine and StateFlow. We'll use SimDriveLine to add a 4-speed transmission to the vehicle, including clutches and planetary gears. We'll then use StateFlow to specify the controller for the powertrain. When we're finished, we'll see how the vehicle performs during 2 drive cycles, one at full throttle and another where we cut the throttle after 40 seconds. I'll now switch over to Simulink so you can see how this is done. Here's our vehicle powertrain model. It consists of an engine, torque converter, a single-speed transmission, and in this subsystem we see a differential gear which splits the torque between the left and right rear tires. This is the model of the longitudinal vehicle dynamics, and here's where we specify the incline of the hill. If we run the simulation, you can see the vehicle speed maxes out at about 6 seconds. At 30 seconds, when we encounter the hill, the vehicle speed slows slightly. We wish to replace this single-speed transmission with a 4-speed transmission. We've prepared the model in advance, so we'll simply delete the single-speed transmission and then drag and drop the 4-speed transmission plus controller into our model. We'll connect the 2 mechanical connections, route the vehicle speed to the controller, and now take a closer look at the transmission. It consists of 2 planetary gears that control the gear ratio between the input shaft and the output shaft. The clutches control which gear we have selected and therefore the gear ratio. This clutch schedule shows which clutches need to be closed in order to be in the different gears. So for example, to be in first gear, clutches A and D need to be closed. We need to specify the automatic transmission so that it closes the proper clutches at the right time. The transmission controller model has been specified in StateFlow. Here we see the different states corresponding to the different gears. So for first gear, according to the clutch schedule, clutches A and D need to be closed. In second gear, A and C need to be closed. In third gear, A and B need to be closed, and we can see that in fourth gear, clutches B and C need to be closed. Now that we have specified our transmission controller, we can rerun the simulation to see how the vehicle performs. We could see during the simulation that the state that we are in is animated, and we can see from the results of the simulation that the vehicle can now reach 200 kilometers per hour before it reaches the hill and slows down. Finally, we'll test this system with another drive cycle. We ran this with an open throttle test where we simply kept the gas pedal all the way down. We'll now cut the throttle after 40 seconds after we are on the hill to see what happens. So we rerun the simulation, and we can see that the vehicle still reaches 200 kilometers per hour, slows down after it reaches the hill, and then after we cut the throttle, there is no power coming from the engine and the vehicle slows dramatically. This demonstration has shown how we can use SimDriveLine to model a 4-speed transmission and StateFlow to model the transmission controller.